This is Praveen, and today we will see one of the important topic in electrochemistry, and that is electrolysis. Now look at, when we talk about electrolysis, there are two terms which are being involved over here. One is electro and the other is lysis. Now what do we mean by electro? The term electro stands for electrical energy and lysis stands for breaking or cleavage. In this term, in terms of electrolysis, we say decomposition. Now, it is very important to understand there is a difference between ionization and decomposition of an electrolyte. Now, let's say we have an example of NaCl. Now, NaCl on ionization will give Na plus and Cl negative ions. Now, because the ions are being produced, this phenomena is nothing but ionization. And the important part is this process is spontaneous. That means it will take place by its own. So whenever NaCl is being put into water, or whenever it absorbs some moisture, so its ions becomes free to move, and the process will be termed as an ionization. However, if this NaCl is being decomposed, when we say decomposition, so NaCl is being made up of sodium and chlorine. So if we just get Na solid and chlorine gas from this NaCl, the phenomena will be termed as decomposition. Now, important thing is that this decomposition is non-spontaneous. And when we say this is non-spontaneous, this does not take place by its own. Now, it will require an external agency to carry out. And that's why this decomposition is being carried out by passing an electric current. And the device what we have been using, or the assembly we have been using, is nothing but an electrolytic cell. Now, what is this electrolytic cell? This electrolytic cell comprises of a vessel. It has two electrodes. Now, again, these two electrodes can be platinum electrodes, can be of certain metals like that, and then it also constitutes of an electrolyte. So it contains a vessel, it contains an electrolyte, and there are electrodes. Now, because let us take an example of NaCl. If we just put NaCl, or we take aqueous NaCl, or we take fused NaCl, let's say we'll take first fused NaCl. Now, when we are taking fused NaCl, that means what? Na plus and Cl negative ions will be there, because ionization takes place of its own. It's a spontaneous process. However, now we want to acquire Na solid and Cl2 from this NaCl, fused NaCl. Now, for that particular purpose, we need to pass an electric current, because this non-spontaneous redox reaction, now this has to be a redox reaction which we are going to discuss further. This non-spontaneous redox reaction has to be carried out by passing an electric current. Let us take one more example for this one. If I say I have H2O, and this H2O gets converted into H plus and OH negative, so this is ionization. However, if I prepare H2 gas and O2 gas from this H2O, then this has to be decomposition. Now, this needs to be very clear. We do not require an external agency to carry out ionization. However, we'll require an external agency if we want to carry out decomposition, because this is a non-spontaneous process. Because this is a non-spontaneous process, and hence in an electrolytic cell we will require an external agency, that is we pass an electric current through battery so as to carry out this decomposition or electrolysis. So from this discussion we can define electrolysis as, we have two definitions. We can just put on two definitions. The one is, the first definition that we can say is, what is an electrolysis? Electrolysis is decomposition of an electrolyte by passing electric current through it. Now another definition can be termed in such a manner that what we are doing over here, we are carrying out a decomposition. That means we are carrying out a non-spontaneous redox reaction. So electrolysis can also be defined as carrying out a non-spontaneous redox reaction by passing electric current through it. So now the important thing is that we have been carrying out a non-spontaneous redox reaction by passing an electric current. Now this electric current need to be an external agency. So the definition is being clear to us. It is not basically an ionization, it is a decomposition. So we have defined electrolysis into two ways: decomposition of an electrolyte, or we have been saying carrying out a non-spontaneous redox reaction. The decomposition of an electrolyte is a non-spontaneous redox reaction, which we are going to discuss further. Now, after knowing about these two definitions, let us now just talk about the mechanism, how do the electrolysis is being taking place. What is the mechanism? How does this is a non-spontaneous redox reaction, and we are carrying out this non-spontaneous redox reaction by passing an electric current, okay, which is an external agency. So let us just consider we have an electrolytic cell and we have been carrying out the electrolysis of fused NaCl. Let's say we have a vessel, we have two platinum electrodes, and we are using electrolyte as fused NaCl. So we want to carry out the electrolysis of fused NaCl. So here is our battery, isn't it? Now we need to understand this mechanism in steps. The first one is that the electrolysis takes place in two steps. There are two processes that have been carried out during an electrolysis. The first one is a primary process. And what is this primary process? Basically, the primary process is discharging of ions. The primary process is discharging of ions. Now look here, whatever the ions, NaCl, because ionization is a spontaneous process, we have taken fused NaCl, so this will possess Na plus and Cl negative ion. Now, solid NaCl, though it possesses Na plus and Cl negative ion, it could not conduct electricity. Why? Because they have been strongly bonded by the ionic bond. Now in the fused state or in aqueous solution, this Na plus and Cl negative ions becomes free. But though they are free, we will require an external agency to decompose NaCl. Now what happens if we just pass an electric current through this one? So this is a positive electrode. So this Cl negative will try to move towards a positive electrode and Na plus will move towards a negative electrode. When the Cl negative moves towards the positive electrode and Na plus moves towards the negative electrode, the primary process says there is a discharging of ions. Now at the surface of the electrode, here at the surface of the electrode, the Cl negative discharges to form Cl and gives away an electron. Now look here, this is a discharging. Now because there is a loss of electron, this has to be an oxidation reaction. This is oxidation. So this is a loss of electron. The Cl formed and the electron will move towards the positive pole of the battery because the opposite charges will attract. Sure. Meanwhile, the same number of the electron will come down from the negative pole of the battery and move down over here, wherein this Na plus will take this electron to become Na. Now look here, again there is a loss of charge. The charge has been removed. There is discharging of ions. Now because there is a gain of electron, this has to be reduction. So the primary process in electrolysis is nothing but discharging of ions. In the first process, there will be discharging of ions. Now, generally we say this as an anode and this as a cathode. Now, why this is an anode and why this is a cathode? Because most of the times what happens, we say positive electrode is an anode, but it's not like that. In electrolytic cell, the negative is an anode and the positive is a cathode. Now, how can we remember that? We know that the electrode on which the oxidation takes place need to be an anode. But there is a story behind that. If we just talk about anode and if we just talk about cathode, look here, I have just denoted this by K and not by C. Now why this is so? Because there is a story. Now in Latin, anode come from ana plus hodos. And what is this ana plus hodos? Ana is up and hodos is way. So the electrode where the movement of the electron is into the upward direction is an anode. So we say, what is anode? Movement of electron in upward direction. That means away from electrolyte or medium. So the electrode on which the movement of the electron is away from the electrolyte, anahodos, upward movement of the electron need to be an anode. However, the simple thing is that the electrode on which the oxidation takes place need to be an anode. Similarly, if we just talk about cathode, what is cathode? Now, CATHODE, cathode, came down from kata plus hodos. Now, what is kata plus hodos? Kata stands for down and hodos stands for way. That means the movement of electron in downward direction, that is into the electrolyte or medium. So where the movement of the electron is in the downward direction into the medium, then it needs to be a cathode, and that is why it is being denoted by K and not by C. Hope this will make you understand. Another thing is that the electrode on which the reduction takes place. So we can say anode wherein oxidation takes place and the cathode wherein reduction takes place. So we'll come back to our mechanism. The primary process was discharging of ions where the ions first of all get discharged. Now where are these ions from? These ions are from the ionization. So first of all, what happens if we just take a fused NaCl? There is an ionization, and when we pass electric current, there is a movement of these charged entities, that is ions, and they move down towards the oppositely charged electrodes. First of all, where they will get discharge. Now the second process is secondary process, and this secondary process is nothing but formation of molecule and once the molecule is being formed and deposition of solid. So if the molecule is being formed and it is solid, it will get deposited, or if it is a gas, it need to be liberated. Liberation of gas. So this has to be a secondary process. Now let us understand this into this electrolysis of fused NaCl. In the primary process, we got Cl and we got Na. Now what happens? This Na need to be aqueous, as Na plus will be aqueous. What will happen in the secondary process? There will be a formation of chlorine molecule. Now this is a chlorine which is being obtained in an atomic form. Now likewise 2 chlorine will combine to form Cl2 gas. So there will be a formation of molecule first, and this gas will liberate from here. So Cl2 gas is being liberated at anode. Similarly, the Na aqueous will start depositing over here. It becomes Na solid and it will deposit over here. So this will become Na solid. Because it's a solid, it will deposit, whereas chlorine is a gas, it will get liberated. Now in this way, we get chlorine gas and sodium solid by passing an electric current. And this is how the electrolysis takes place. And we say that sodium is being deposited at cathode and chlorine is being liberated at anode. But we need to just understand it's not actually true if we just take aqueous NaCl. If we take aqueous NaCl, the entire thing will be different. Let us just come back to this one. If we want to carry out the electrolysis of aqueous NaCl, now we need to understand this aqueous NaCl, apart from Na plus and Cl negative ions, will also possess H plus and OH negative ions. How come? Let's say this is an electrolytic cell wherein we have been using 2 platinum electrodes. Okay, and the electrolyte we are using is aqueous NaCl. And to carry out the electrolysis, we are again using an external agency. That is, we are connecting this with a battery. So this is an anode and this is a cathode because positive is being connected. And again, we know that here the movement of the electron will be in the upward direction. However, when we use NaCl aqueous, we have Na plus, Cl negative, H plus and OH negative ion. That means to say what? We have 2 positive ions as Na plus and H plus, and there will be 2 negative ions, Cl negative and OH negative. Now there will be competition amongst them to reach down to the oppositely charged electron. Like Cl negative and OH negative both will try to move down toward anode, and Na plus and H plus will move down towards the cathode. The primary process need to be a discharging of ions. However, there come a different concept and an important concept which we used to call as discharge potential. Now, what is this discharge potential? It is the minimum potential required to discharge an any ion. Okay. Now, for its discharge, whatever the minimum potential is being required, because we have been passing an electric current, we have been passing electricity over here, the minimum potential required for an ion to get discharged, okay, is called as a discharge potential. Now, we have seen that there is a primary process. In the primary process, there is discharging of ions. Now, we have competition amongst two positive ions and amongst two negative ions. If we just talk about Na plus and H plus, these are two ions, the potential, now both of them will undergo reduction. They are supposed to undergo reduction, isn't it? So whichever will be having higher reduction potential, or whichever will be in a higher position in an EMF series, okay, that will be having a greater reduction potential or standard reduction potential, and it will be having a greater tendency to get reduced. So, if we just talk about Na plus and H plus, if we just compare the SRPs, the standard reduction potential of hydrogen is always greater than standard reduction potential of sodium. And that is the reason why the discharge potential, the tendency to get discharged will be greater for H plus ions. And we'll say that H plus have lower discharge potential than Na plus. So the tendency to get discharged will be greater for H plus as compared to that of Na plus. Similarly, if we just talk about these two ions, Cl negative and OH negative, now these both are supposed to be oxidized. So when we say they are supposed to be oxidized, that means what? Whoever will be having a greater standard oxidation potential is supposed to be oxidized first. So out of these two, Cl negative, so SOP, standard oxidation potential of Cl2 will be always greater than standard oxidation potential of OH negative. So Cl negative will be greater than OH negative, and that's why this will be having a lower discharge. Now to get oxidized, Cl will require a lower potential. So we say that Cl negative have lower discharge potential than OH negative ion. Now it's been clear. H plus is having a lower discharge potential amongst H plus and Na plus, and Cl negative is having a lower discharge potential amongst Cl negative and OH negative. So let us just concentrate the primary process and the secondary process that will take place in electrolysis. Now, if we say the primary process over here, which is nothing but the discharging of ions, we know that the primary process. What is the primary process? The primary process was discharging of ions. And out of the two negative ions or anions, who will win the race? Cl negative is going to win the race. So Cl negative will approach the anode, wherein it will get discharged by losing an electron. So that's an oxidation. Similarly, if we just talk about amongst the positive ions, H plus and Na plus, H plus wins the race, and this H plus will move towards the cathode. So this H plus will acquire an electron to form H, which is reduction. So If we just talk about the Cl negative, it reaches over here, it becomes Cl, and the electrons moves towards the positive pole of the battery. The movement of the electron is in the upward direction. This is an anode and a chorus. Similarly, the same number of the electron will enter through the negative pole of the battery into the electrolyte. So there is downward movement of the electrons, and this is a cathode, chorus. So in the first process, that is primary process, there will be discharging of Cl and H plus. Now, after that, there will be the secondary process. And what is a secondary process? Secondary process involves formation of molecule, okay, and then liberation of gas or deposition of solid. So we just look at this particular phenomena. What will happen at this juncture or over here, Cl and Cl, there two Cl will combine to form Cl2 gas. So chlorine gas will be liberated at anode, whereas H and H combine to form H2 gas, and here hydrogen gas will liberate from cathode. Now look here, there is a difference. If we just talk about NaCl aqueous is giving chlorine gas at anode and H2 gas at cathode. Isn't it? Whereas earlier, when we have talked about NaCl, which was fused, we got chlorine at anode and we got sodium solid at cathode. So by a slight change of condition, that means aqueous and fused, because now water is also playing a role, we get different products. The most important thing is that what is being remaining into the solution, the remain in the solution is Na plus and OH negative. This will combine to form NaOH, and that's why we say the solution is alkaline. Or this can also be used as a method of preparation of NaOH, wherein the chlorine gas is being liberated, hydrogen gas is being liberated at cathode, chlorine at anode, and NaOH is being prepared. This can be also the method of preparation of NaOH. Now, what are the important things that have to be understood over here is, number one, the electrolysis always takes place at the surface of the electrode and not inside the solution. The electrolysis always takes place at the surface of the electrode. Let us just write this down. The point number one is the important concept, the important topics are that. One is electrolysis takes place on the surface of electrodes and not inside the solution, that is electrolyte. Why? The discharging was being taking place at the surface of the electrode. Okay, discharging of ions was at the surface of the electrode and not inside the solution. Second thing is that movement of ions inside solution and movement of electrons in electrodes. So we can say there's a movement of ions inside the circuitry. In the external circuit, there's a movement of electrons. Basically, these are metallic conductors. Now because the electrodes are metallic conductor and this is the electrolyte is an ionic conductor. So the movement is ions into the solution and electrons in the rod. As long as these ions will move down, the electrolysis is being carried out. Third, because we have said there is an oxidation and reduction, so this is a redox reaction, which was non-spontaneous. It was not taking place by its own. So this is electrolysis is carrying out non-spontaneous redox reaction. So this is a redox reaction which is being carried out. Fourth one, the electrode on which the oxidation takes place is an anode. And reduction is cathode. However, the story behind that, the movement of the electron in the upward direction and the downward direction is already being covered. This is an anode up way and cathode down way. The fifth one is that when we talk about electrolysis, the product form will always depend upon the discharge potential. When there will be more than one type of ions, that means either positive or negative, then there will be always a competition which will be decided who will win on the basis of discharge potential. That's all about the mechanism of the electrolysis. I hope you understood the topic. Thanks a lot.